vCenter itself has become a significant part of the operational efficiency of your software-defined data center. Many other components rely on vCenter for the automated creation of virtual machines, for the monitoring of systems, and so on. And for us to have a significant period of unplanned downtime in vCenter itself, we can actually occur outages in other applications. So at this point, the very quick restoration of VMware vCenter servers systems becomes critical. Let's have a look at how this is done in lesson number 8. We'll look at the importance of vCenter, we'll look at how vCenter HA works, and we'll identify the requirements for vCenter HA, and at the end, we'll have a little bit of a demonstration of it. Here in this slide, you can see some of the products that rely on vCenter Server. Things like vRealize Automation, NSX, Orchestrator, Site Recovery Manager, vRealize Operations, Log Insight, Horizon, and other third-party integrations like backup, portals, costing engines, storage providers, and on and on. The list continues to go on. All of these systems rely on vCenter to execute tasks on our ESXi hosts and with virtual machines. Okay? So vCenter has now become foundational to the good operational management of our software-defined data center. So we want to make sure that we have all kinds of solutions in place to make sure that if there is an outage in any of the systems that vCenter relies upon, that we can get vCenter to be up and running as quickly as possible. Now, certainly we have vSphere HA, which is if an ESXi host fails, we'll know what virtual machines went down with that ESXi host, and we'll restart those virtual machines on other hosts. And if vCenter Server itself was one of those virtual machines, vCenter, of course, will restart on another one of those ESXi hosts. But as we know, sometimes hard crashes, systems that go down really hard, can incur other sorts of failures where simply restarting it doesn't necessarily solve the problem. What if a disk partition, for example, becomes corrupted in a Linux-based file system or a Windows-based file system? It would be nice to have a backup to the backup mechanism, right? And if the first backup mechanism was vSphere HA, it would be nice to have a second vCenter appliance ready to take the place of a failed vCenter. And that's what vCenter High Availability does for us. What it does is starts with your initial vCenter and clones that vCenter to create a passive node. To solve the split brain issue, we also create a third node to serve as a witness or a quorum node. Okay? So when we turn this on, there's a process that we go through that says, all right, let's pick 3 separate ESXi hosts for each of these nodes to run. Okay? We'll create the passive node so that if there's a failure on the active node, the passive node can just fire up the services, take over the IP address of the dead node, and resume operation as if nothing had happened without any sort of intervention from the part of the vSphere administrator. It's built into vCenter, so all we have to do is turn it on. So when there's an active node failure, well, let's look at a little bit of this infrastructure. Let's try this again. So let's have a look at what happens during the failure of an active node. Now, the first thing to note is that when vCenter HA is turned on, there's some replication that happens on an HA network. So a secondary virtual NIC is added to your vCenter server, and it's attached to another network so that our vCenter HA network can then execute database and file-based replications. Let's look at how this works. If that primary vCenter should fail, the management network is transferred to the passive vCenter node, where that vCenter will fire up those services and take over where the failed node had stopped. Now, if the passive node should fail, well, that's fine because the active node was still available. We'll become alerted in the vSphere client that the vCenter passive node has failed, okay? And we can either wait for vSphere HA to restart that passive node. We can manually restart that passive node if there was some sort of corruption in the file system or for some reason, I don't know, something else had occurred. Or we can choose to completely rebuild that passive node from scratch by creating another clone from the active node. If the witness node should fail, the same thing will occur. We'll be notified that the witness node has failed, and it will give us options as to how to recover that witness node. So there are a lot of benefits to the vCenter HA set of features, right? The vCenter appliance now becomes more resilient, and it protects not only against hardware failures, but host failures, application failures, and corruptions that might occur during the physical failure of an ESXi host if, for example, a disk partition should become corrupted or something to that effect. The recovery is far less in time because you already have a virtual machine powered on and ready to start the services. It's not instantaneous, okay? The passive node's services are not started, okay? We simply have a service there called the watchdog service that says, uh-oh, I'm the active node. I better start all of vCenter services so that we can then take over the running and management of our ESXi hosts. Okay, so we have a good recovery point objective. There's no data loss. Recovery time is within minutes. The nodes between the active and passive node can be slightly geographically distant. Within 10 milliseconds of latency is what we're looking for. Data center to data center with a short geographical distance. Those sorts of things. Not only that, but we don't require any external third-party technologies to enable this. Everything is done with built-in technologies that we know, like Postgres replication and rsync for file configuration-based replication as well. So it's very, very simple, well-known sorts of technologies that are implemented in order to create our vCenter HA set of features. Requirements say that we need at least ESXi 6.0 with a minimum of 3 hosts. A rule in the system is automatically created if we're in a cluster, and that rule says that these 3 nodes should be on separate hosts, so the failure of one of these hosts doesn't take out more than one of the nodes. When it comes to vCenter, we need vCenter version 6.5 or later, okay? And we need a small or larger sized appliance node to meet the recovery time objective. If you use a tiny node, that system only has 2 vCPU, I believe, and like 8 to 12 gigs of RAM, something like that. It's a little bit slower of a system. So you need a larger system, something small or better, to meet a better time objective, recovery time objective. Okay, and you need enough disk space on the appliances themselves to store and collect support bundles for the failed nodes. Now, latency between the active and passive and witness nodes needs to be within 10 milliseconds, and that network that executes those replications should be on a different subnet than the management network. This way, if the management network should fail, we're not going to lose replication capabilities, okay? Now, we don't actually require a separate license for this, And you don't need a separate license for the standby or passive node. A single vCenter server standard license gives you the capability of running vCenter HA and all 3 of these nodes. So why don't we have a look at a demonstration, and then we'll come back and we'll finish this module off. Welcome. My name is Joe Cooper with VMware Education. You know, as vCenter Server becomes a more and more important component in our software-defined data center, it's ever more important that we are able to take proactive steps to protect it. Now, there are a number of ways to do this, of course. Simply using vSphere High Availability does a great job of protecting vCenter Server against hardware failures. Enable HA in your cluster. When patching or performing or other maintenance on vCenter, you can always take a snapshot of your vCenter appliance VM to be sure that you have a rollback plan should something go wrong with your change. You can even rely on your backup team to ensure that the vCenter appliance VM is backed up along with all of your other virtual machines in the environment, or even do an out-of-band file-based backup before you make changes or upgrades. But isn't it time that we bring some clustering features directly into vCenter Server itself so that we can at least minimize the downtime and increase the reliability of recovering your vCenter in the event of a hardware failure? So vSphere HA is great, but I want something faster and more reliable for such an important component, right? So with the release of vSphere 6.7, VMware introduced vCenter Server HA. It works by creating a replica node that runs passively, receiving any changes made to your active vCenter node. Then, to compensate for a split brain condition, we of course implement a witness node. So in this video, we're going to show you how to configure it all. It's really simple, and there's really only one single prerequisite that you have to do. What you need to do is build for yourself a replication network. What's going to happen is an extra virtual NIC is going to be added to your vCenter virtual machine. This will be placed on a separate network from your vCenter production network, okay? And it will be used explicitly for the replication of files, configuration files in vCenter, and database changes. So what I've done here to my distributed switch is added a replication virtual machine port group, okay? And I've actually put it on a new VLAN. If you're using a standard switch, you need to go to each of your ESXi hosts and add a virtual machine port group for that. That's the only prerequisite that we have before we dive in and start a very simple, well, I don't know. There's a few questions to answer. Before we start a wizard that enables vCenter HA. So let's go ahead and do that. We've got a replication network, and we've got our vCenter server, which I'm going to point you to right here. As we go to the summary, we can see that it's on the distributed switch. Now, before I ran and recorded this demo here, I practiced a little bit. And the wizard actually created the virtual NIC for me, but you don't have to have this pre-created, okay? So let's go ahead and head back over to vCenter. And we're going to go to configure, and you'll see under settings, vCenter HA. Okay, prerequisite, create that HA network. It's got to be a private network separate from the management network used for that internal communication between nodes. Less than 10 milliseconds of latency, if at all possible. We are also going to need static IP addresses for all of the nodes on that network. And we're going to define that in this wizard. Okay, so the first thing that we're going to do is select the network for the active node. Let's browse. We'll see the networks that are available. That's the new virtual machine port group that I had just created on VLAN 6. I'm going to click OK. And now what we'll have the system do is automatically create the passive node as well as the witness node. And it's going to do it simply by cloning your existing vCenter server. Okay, so it looks first of all at our existing vCenter server. Okay, it's in the active node is called VCSA_RC3. That's what I named my virtual machine. Okay, we can see it's running on a cluster. There's the host name that it's running on. Okay, this is the production network that its management NIC is on. This is NIC 0 for that virtual machine. And the data replication network will be on vCenter HA NIC 1. Okay, right? And that's going to, sorry, the vCenter HA NIC 1 will be on the data center replication distributed switch port group. Okay, the next thing that we're going to do is run through this wizard and define things for the passive node and the witness node. And in particular, we're going to need to give it IP addresses and the like. Okay, so let's go ahead and edit the passive node. What's the virtual machine name? It automatically creates, starting with the original active node, and gives it a -passive tag on it. And I'll select a place for it in my inventory. I'll put it in my VDC management folder. I'll put it in my old home lab cluster. Okay, and I'll put it on a data store. In this case, I've got a nice solid state device based data store. Excellent. Now I'm going to choose the management network. Right? This is going to be the same management network that my active virtual machine is on. And now I'm going to choose the backend HA network, which I had earlier created. There's that data replication network. Next. Okay, looking good to me. We'll do the same thing now for the witness node. Okay, it's named -witness. That's the way it populated the name. You can rename it. There's the virtual machine folder it goes in. There's the cluster that it's going to run on. There's the data store that it's going to run on. And now the witness node does not have an active network. It's only going to use the replication network to do its quorum duties. Okay, so we'll put that on the data replication network and hit next. Okay, now I've set up the virtual machines themselves. And as I click next, I need to set up their IP addresses. Give it an IP address for the backend replication. In my case, it was VLAN 6. So that's the subnet I'm going to use. And just for conformity, so I know what's going on, I'll give it the same last IP address there. On the back end, since I don't need to route any traffic, I don't need a default gateway here. Okay, we're going to do the same thing now for the passive node. The passive node, we'll give it a different IP address. That one looks good to me. Okay, we'll give it a 24-bit subnet. You can do the subnet mask or the prefix length. And we'll do the same thing for the witness node. .6. How about 77? Okay, and a 24-bit subnet mask or prefix, and hit finish. That's it, folks. Now, what's going on? It's setting up vCenter HA. Let's go ahead and have a look for ourselves at the tasks that are happening. So the first thing that's going on here as we deploy an HA cluster is that it's cloning a virtual machine. Okay. Now at this point, we know that our vCenter is a pretty big VM. Okay. This passive node is going to be a clone, really going to be a full clone of the active node. And we can see here its management IP address. We can see its HA IP address. The passive node has an HA IP address, and the witness node has an HA IP address. I want you to notice something here as well. The passive node has the same management IP address as the active node, but it's grayed out. When the passive node is powered on, the virtual NIC is not active within the guest OS. It's only until we detect a failure in the active node does the passive node become active It starts all of vCenter services, and then it engages, turns on, enables the primary virtual NIC, taking over the IP address of the old active node. This way, any systems that were relying on vCenter will now rely on the passive node. This way, when I open up to VCSA01, I'm now hitting the passive node instead of the active node. In other words, there's no other configuration change that's going to be required in any of the other systems that use vCenter, which is a really great thing. Now, from this point, we'll go ahead and let this finish. I'll speed up the video, but we know this is going to take some time. Okay, so we'll be back in just a moment. Well, it looks like things are pretty good here. We've got an active, a passive, and witness node, and they appear to be up and running. We've got our IP addresses for the back end. We've got 192.168.1.72 on the front end, only on the active node. And then we have the 3 HA network IP addresses for the back end. Now we have the ability to initiate failover in a manual way if that's something that we want to do, where the passive node now becomes active and the active node becomes passive. Well, that does it for me. It looks like things are hanging in there, and we've got our vSphere HA cluster with all 3 nodes on separate ESXi hosts. Here we have the primary node, active node on ESXi03. We've got ESXi02 running the passive node, and we've got ESXi01 running the witness node. Our vSphere HA cluster is up and running. Thanks so much. I hope you've enjoyed this video and found it useful. Good day, good night, good evening. See you later. So that does it for vCenter HA, where we understand now the importance of vCenter to the environment, and we understand, of course, the importance of protecting it with these vCenter high availability services, which we know how they now operate. We understand a little bit of the architecture of this, and we understand the requirements for it as well. When it comes to our virtual beans scenario now, we have a pretty good idea of how we're going to manage this system. That we've got vCenter up and running, we've got vCenter HA protecting these services, we're going to do regular backups, file-based backups of vCenter HA, and we're going to monitor vCenter so that we are sure that all of the systems that rely on vCenter can do their jobs and do those jobs well. So we've got a pretty good sense now of vCenter in general. We understand that vCenter is an application or set of applications that run within a virtual machine that we call the vCenter Server Appliance, which is based on VMware's Linux distribution called Photon OS. We understand that the vSphere client is one of the services that runs on the vCenter appliance, and it's an HTML5 based user interface that we access through a web browser. We understand how permissions work within this environment. We understand how the single sign-on server works within the environment. We have a taste of the appliance management interface that operates on port 5480, so we can look at things like monitoring the appliance and backup, and we can look at exporting logs and so on. And we have ourselves a very nice system for high availability of vCenter itself to keep vCenter up and running. Well, I hope you've enjoyed this particular module. When we come back, we're going to have a look at vSphere networking. So stay tuned and we'll see you in module number 5.